Dear friends, once again I am happy to meet you through this video. We have been discussing about coal-based power plant, diesel power plant. Now in this video I am going to talk about gas turbine power plant, which is another important uh, energy producing device. Gas turbine, it is having more advantages than other types of power plants because here we can use compressed natural gas also, which is pollution free, but we could not generate huge amount of electricity. It is limited 100 megawatt. Likewise only we can go for gas turbine power plants. It is a turbo machine, basically like a steam turbine. In the steam turbine we are expanding the vapor, whereas here we are going to expand gas. So we can have classification of gas turbines as based on the factors like combustion, path of working substance, action of combustion gases in turbine. Based on these three factors, we are dividing the gas turbine. The combustion process means we have the constant volume gas turbine, constant pressure. Path of gases, we have open cycle gas turbine, closed cycle, and semi-closed cycle gas turbine. Based on the action of gases, we have impulse and reaction gas turbine. Let me repeat. So based on three factors, we are dividing the gas turbine classification. That is, three factors are combustion, path of gases, and action of gases. In the combustion process, whether the combustion takes place at constant volume or constant pressure, whether the gas flow, it is the open cycle or closed cycle or semi-closed cycle. Third one is action of gases, whether it is impulse turbine or impulse reaction turbine. If you quickly go through this working of gas turbine, natural gas is used as a fuel, whereas in the coal-based coal was used as a fuel. In the diesel power plant, diesel was used as a fuel, whereas in the gas turbine, natural gas is used as a fuel. Here we have the compressor, very important component, combustion chamber, gas turbine. These are the three important components. The compressor, what the compressor does is it draws the air and pressurizes and feed to the combustion chamber at a speed of 150 miles per hour. The fuel will be injected through the nozzle like steam, that is natural gas, and it will be burned around 2000 degree Fahrenheit. That is, combustion is taking place at very high pressure and very high temperature. The gas turbine, there is a stages of expansion is taking place, like array of expansion, stationary blades and the rotating blades, stationary and the rotating, stationary and the rotating likewise. So in the stage wise we are generating the speed. That is another advantage of this type of gas turbine. Say this you can say the practical example. The first drawing, first figure shows the single combustion chamber which is mounted on outside of the compressor exit. That is the compressor exit section of the gas turbine with the multiple burners mounted through engine casing into holes in the annular combustor. Here, annular combustion hardware. This is components convention diffusion flame combustion hardware. Here the combustion liner, nozzle, gas fuel nozzle. This is a gas fuel nozzle. This is called a nozzle. Okay. The difference between IC engine and gas turbine, which is another important area we have to touch upon. In the diesel engine, ignition and lubrication system is complicated when compared to the gas turbine. The gas turbine ignition and lubrication system was simpler. Weight per horsepower developed is high in the case of IC engine. Weight per horsepower developed is less. Exhaust gas produced is more in the case of IC engine, whereas here is comparatively less. Since air is used for combustion, natural gas is used as combustion fuel. Thermal efficiency is higher for diesel engine, lower for gas turbine. Fuel cost is high for diesel engine, low for gas turbine. Work developed is less IC engine, is more per kilogram gas turbine. Exhaust gas is okay. IC engine cannot be driven at a high speed, whereas gas turbine up to 40,000 RPM also we can run. For IC engine we need a flywheel, whereas flywheel is not required in the case of gas turbine. See, look at this, how we are comparing with the diesel engine. The top one is gas turbine, the bottom layer is IC engine, that is admission of air, compression, combustion and exhaust. Here also admission, combustion and expansion. This is a diagram depicts the comparison between diesel engine and gas turbine. In diesel engine, we have followed a diesel cycle to operate the plant, whereas in the coal-based power plant, that is thermal power plant, we use the Rankine cycle, whereas in the case of gas turbine, we are going to use a Brayton cycle as the ideal cycle for gas turbine. Here, gas is expanded. As I have told, compressor, combustion chamber, turbine are the important and major components. If it is closed, if it is connected to heat exchange, it is called as closed cycle gas turbine. Brayton cycle, it consists of four thermodynamic process: isentropic compression, constant pressure heat addition, isentropic expansion, constant pressure heat rejection. Always heat addition and heat rejection are taking place at the constant pressure. Expansion and compression always by means of isentropic. The PV diagram you can easily look. Efficiency, we know that output by input. Based on that only we are deriving the efficiency. Look at this, yes, improvement of gas turbine. As we have seen improvisation of Rankine cycle, here also we have few important points. Increasing the turbine inlet temperatures. Efficiency of turbo machine components, the turbine and compressor. Adding modification to the basic cycle by intercooling, regeneration, recuperation and reheating. These things will enhance the gas turbine power plant efficiency. This actual gas turbine, Brayton cycle with regeneration, effectiveness of the regenerator, factors affecting thermal efficiency, ratio of the minimum to maximum temperature and the pressure ratio, Brayton cycle with intercooling, reheating, regeneration. These are the things to improve efficiency of the gas turbine power plant. This is a comparison between open cycle and closed cycle power plant. The combined cycle power plant will be using both gas turbine power plant and steam turbine power plant. In the integrated gasifier combined cycle, gasifier and